Hey guys, welcome to Lesson 12.3, Measures of Central Tendency and Dispersion. Our objective for today is that I can find the mean, median, mode, and range of a given data set. So we're just going to kind of rewind. Our measures of central tendency are these mean, median, and mode. And an outlier is a data value that is much greater or less than other values in your data set. Now, I know it's a little bit of review, but mean, we are going to add up all of our data values, and we are going to divide that by the total number of data values. The median is the middle value in a data set when they are arranged in order, and if there's an even number of data values, we need to find the average of those two middle ones. And the last one, the mode, is the one that occurs most often. You can have no mode, one mode, more than one. It all depends on those data sets. Okay. So our first question is a list of bowling scores. We want to know the mean, median, and mode of the bowling scores listed below. We want to talk about which one best describes that data. So our first step is going to be to put these numbers in order. So we've got 104. 104, 104, 109, 113, 117, 136, and 189. So we are going to look for, we can find our mean. So in order to do that, we need to add up all of our numbers. I'll trust that you are capable of doing that on your own. So we have 976 over 8, which is the number of bowlers we have. And so our mean is a 122. Our median is the middle number in our data set. So we start from the edges, work our way in. We've got two values that are in the middle there. This is an even number of data values. So we need to take the average of 109 and 113. So 109 plus 113 divided by 2, and that is equal to 111. And the mode, which score comes up most often, mode most. That is 104. There are 3 entries for that piece of data. So which one of these best describe the scores? Well, if we look at the mean, that's the average of them, but all but 2 of the scores are below that mean. So that's not a really great description of what our data looks like. The mode, that one is 104, but those are the 3 lowest scores that we had. Doesn't really describe the data too well. 111 probably gives us our best description here. Okay. Letter B, we want to know what are the mean, median, and mode of the test scores listed below. We want to know which one best describes this data. So the first thing we need to do, let's write these data points in order. So we start off, we've got 72, 77, 77, 82.
I was making up data values.
85, 87, 88, 90, 91, 95. All right, so when we're doing the mean, we're going to add up all of those data points. And the sum of all of those test scores is going to be 844. And there are 10 tests. 844 divided by 10 is 84.4. All right, so we know there's an even number of data values, so we're going to have to do an average here. So Ms. Zirzo is working her way in towards the middle. We find we've got 85 and 87 are our 2 middle scores. 85 plus 87, we're going to divide that by 2, and that equals 86. And which score occurs most often, the mode? That would be 77. There are 2 instances of a 77. So which measure best describes the scores? Well, the mode doesn't really describe it. Most of the data is above that point. Our mean is right in the pretty close to the middle of our data set, and the median we know is right in the middle. So mean and median both probably describe this data fairly well. They're both representing the bulk of the data. All right, problem number 2, finding a data value. There will be one on the test like this. For some reason, this has been confusing in the past. So we've got your grades on 3 exams are 80, 93, and 91. And we want to know what grade you would need to get on the next one to have an average of 88. Well, how do we set up an average? We add our data together. And we can't forget we have an x because we want it, what are we going to get on the 4th test? And we're dividing by 4. We want that average to equal 88. All right, so now we're going to add up our numbers in the front, or on the top. We're going to have 264 plus x over 4 is equal to 88. Multiply both sides of our equation by 4. We're just trying to isolate that x. 264 is equal to 352.
Oh, you have to subtract.
Where did you get 88.5?
Oh. Sorry. I'm with you now.
All right, 352.
88 times 4 is 352. I don't know
Yes.
what's wrong with you, Boland.
Okay. So now we subtract 264 from both sides. And x is equal to 88. So in order to have an average of an 88 on the 4 tests, you would need to get an 88% on the 4th test in order to have that exact average. If you want to have it an 88 or better, you would need to get an 88 or better on this final test. So now letter B. If the highest possible score on the 4th exam is 100, is it possible to raise your average to 92? Now this is a question that's going to come up in high school when you start to do the math of what grade do you have to get on a final in order to get an A, a B, C, or even pass a class. And this is the kind of math you're going to do for that. So we've got our 3 original test scores plus x over 4, and we want it to be equal to 92. So again, all those scores add up to 264. We're adding it to x, and it's all over 4. Too low. All right. Multiply both sides by 4 to cancel it out. We got 264 plus x is equal to 368. Subtract 264 from both sides. X is equal to 104. So, can you achieve your goal of getting a 92 in this class? Nope, sorry. Study harder next time. Okay, next up we've got Graham, and he's got sales of 1,280, 1,125, 965, and 1,210 for the first 4 days of the week, and we want to know how much is he going to have in sales on the 5th day to average 1,150. So we add up all of our data points. They're all divided by 5. Mr. Zoe almost forgot the plus x, our 5th data point, and it's equal to 1,150. So add all those numbers up and we get 4,580 plus x over 5 is equal to 1150. Multiply both sides of the equation by 5. And we get 4580 plus x is equal to 5,750. Subtract 4580 from both sides. And x is equal to $1,170. Don't forget your units. We have something with units. Don't forget your units. You will lose half a point, and it will make you mad. All right. So the measure of dispersion is describing how spread out the data values in the set are. And the range is the difference between the greatest and the least data values.
It
Difference.
is one number.
Yes. Range is the difference, so we are going to subtract. All right, so we've got the closing prices in dollars of 2 stocks for the first 5 days in February. We want to know the range and the mean of the data set, and we're going to use these results to compare them. So our highest data point in stock A is 47. Our lowest data point is 25. 47 minus 25 is 22. Okay, so our range is 22. Our mean...
This is not the range.
Nope. You do the subtraction. The mean, we're going to add those all up. It's 160. And it's divided by 5. There are 5 days. That equals 32. All right, now let's do the same for stock B. We've got the range is, the highest is 36. The lowest is 28. So our range is 8. The mean, we add them up. They are 160 again. And we divide by 5, and that's 32 again. So comparing these two data sets, they have the same average price for the stock, but stock A is a lot more volatile. It goes up and down by quite a bit more than stock B does. Stock B is a lot more consistent. So you could possibly make a lot of money on stock A, but you could also possibly lose a lot more money on stock A because it's moving around more. Okay. Letter B. For the same days, we've got the closing price of stock C and D, and we want to do the same. We're going to compare the range and the mean for each of these data sets. So stock C, we have our highest price is 7. Our lowest price is 1, so our range is 6. Our mean, if you add them all up, we've got 21, and there are 5 data points. 21 divided by 5 is 4.2. Stock D, our highest data point is 24. Our lowest data point is 2, so we've got a range of 22. Add them all up, we've got 56. 56 divided by 5 is 11.2. So stock D has, on average, a higher price, but once again, it's much more volatile. It moves much more up and down. So it's a riskier stock. When you guys are looking at your stock market stuff, if you see the 52-week range, that's where the price is over the last year. And if you look and see how big of a spread that is, that'll tell you how consistent that stock is performing. Problem 4, finding measures of central tendency. So we've got a line plot showing the number of students in each homeroom at Jefferson High School. We want to know the mean, median, and range, and how we can use that to determine whether they're equal. So Ms. Zirzo is counting up how many X's we have in each of the columns.
So 4 homerooms have 19 students in them each.
Yep. Okay, so if we want to find the range, the most number of students we have is 24. Our lowest number is 19, so our range is 5. Our mean, if we add up all of them, so 4 19s, 5 20s, 6 21s, 2 22s, 2 23s, and 1 24. When we add all of those up, it's going to be 416. Mean. So we got 416, and there are a total of 20 classrooms when we add up all of those. So 416 divided by 20 gives us 20.8 as our mean. Our median, we're looking for which data point is going to be exactly in the middle. So we've got 20, so we just work our way in from the ends. The zeros is just kind of hopping along here. Just working our way closer. They're getting closer. They're getting closer. Our final 2 points are in 21. So 21 plus 21 divided by 2 is 21. All right, so looking at a line plot, we can talk about whether the mean and the median are equal based on, well, how many of each number fall on each side. Anything you want to add? Okay. So just a different way of representing the data. Our last one, we want to just compare the measures of central tendency. Is the mean for class C greater than or less than the mean for class A? Well, let's look at our 3 sets of classes up there. Class A, that would be a symmetric graph, very clearly broken down the middle. Class B, if we're looking at it, is definitely skewed towards the high end, so that class did really well. And Class C didn't do so hot, and they're skewed to the low end. So we're asked, is the mean for Class C greater than or less than the mean for Class A? Well, we can just look at that plot and say that Class C is definitely going to have a lower mean than Class A. Its data points are skewed much more towards the low side. All right. Is the median for Class C greater than or less than the median for Class A? Well, Class A we said was symmetric, so that median is going to be right in the middle of 3 and 4. So you average 3 and 4, you get 3.5. For Class C, we need to work our way through the data. So we're hopping along. Hey, look, the ones that we have left, it's 2 3s again. So our median is gonna be 3. So is the median for Class 3 greater than or less than the median? It's going to be less than. So our last question is, how can you tell which set of data has a greater mean by comparing the graphs? Well, we can just look to see where are they skewed to. If it is skewed to one side or the other, that is where you're going to have the differences. So we can see that Class C is going to be lower than Class B or Class A because it's skewed to the low side. More of those students scored a 1 or a 2 on the quiz. All right, those are your notes for today. We'll see you in class.